Hello guys, my name is Christy Perez. I am a senior here at Temple University studying health professions, and today I'm going to deliver you guys an informative session about drugs resembling the structures of serotonin and dopamine. I hope you guys enjoy and learn something from this presentation. So the first question is, what exactly is serotonin and dopamine? Let me break down serotonin first. Serotonin is a neurotransmitter that is present in the brain. It carries messages from the nerve cells to the brain, and it also carries messages through the body. It regulates the cognitive and body function, primarily helps with mood, sleep, and digestion. It's produced both in the brain and guts. It's made from tryptophan, and it's also known as the happy hormone because it is able to control our happiness. Let me break it down a little more. So we have here the chemical formula for serotonin, which is C10H12N2O. Molecular weight is 176.24 gram moles. It is a covalent bond. It's biogenetic amine synthesized by tryptophan, hydroxylate by the enzyme triphenylate, which is 5-hydroxylase. It's serotonin 5-HT. It's not a catecholamine due to the lacking of the amino acid tyrosine. And then on your right, you have the chemical structure of serotonin. So how do you find the chemical formula for serotonin? Well, it's quite easy and simple. We're just going to grab the element and the number of atoms and combine them together. For example, carbon, we know we have 10 atoms. For hydrogen, we have 12 atoms. For nitrogen, we have 2 atoms. And for oxygen, we have 1 atom. So what we're going to do is combine them both together, and we are going to create C10H12N2O. So how do you find the molecular weight now? It's quite simple and easy. For the formula, we're going to use atoms times atomic weight. So we know that carbon has 10 atoms, and we know that in a periodic table, we know that carbon has 12.01 gram moles. For hydrogen, we know that we have 12 atoms. We're going to be timesing that by 1.01 gram moles. For nitrogen, we have 2 atoms. We're going to times that by 14.01 gram moles. And lastly, oxygen, which is 1 atom, we're going to be timing that by 16.00 gram moles. Now we're going to plug them in all together. So we're going to write down 10 times 12.01 parentheses plus 12 times 1.01 parentheses plus 2 times 14.01 parentheses plus 16.00. When we plug those in, we are going to get 120.10 plus 12.12 plus 28.02 plus 16.00. Once we calculate all those together, we are going to get 176.24 gram moles. Let's get on to dopamine, which is a type of neurotransmitter and acts like a chemical messenger because it helps to communicate messages with the nerve cells in the human body and brain. A few facts about it is that it is here to increase mood, learning, and behavior. It's responsible to produce pleasure. It helps the brain control movements. The brain does create a 2-step process in order to create this. So the first one is it forms into amino acid trypsin, which becomes into a substance, dopa, and then it begins to form to dopamine. Let's dive a little deeper with dopamine. The chemical formula is C8H11NO2. The molecular weight is 153.20 gram moles. It is also a covalent bond. It is a cathepsin hormone. It's also a part of an amine neurotransmitter. Its shared molecules contribute with catecholamine and triosome. Dopamine is also a levodopa, which is catalyzed by dopa decarboxylase. And then on your right, you also have the chemical structure of dopamine. Now it's time to find the chemical formula for dopamine. It is the same process as before. We're going to combine the element and atom together. So we know carbon has 8 atoms. Hydrogen will be having 11 atoms. Nitrogen will have 1 atom. And then oxygen will have 2 atoms. Same process as before. We're going to combine both the element and the number of atoms together to create C8H11NO2. Finding the molecular weight is the same process as we did before. We're going to be using the same formula, atoms times atomic weight. So we know that carbon has 8 atoms. We'll be timing that by 12.01 gram moles. Hydrogen has 11 atoms times 0.01 gram moles. Nitrogen has 1 atom, and we'll be timing that by 14.01 gram moles. And then oxygen, we have 2 atoms. We'll be timing that by 16.00 gram moles. Same process as before. We'll be combining all of those together to get the molecular weight at the end. So we'll be plugging in 8 times 12.01 parentheses plus 11 times 1.01 parentheses plus 14.01 plus 2 times 16.00 parentheses. We plug those in our calculator. We are going to get 96.08 plus 11.11 plus 14.01 plus 32.00. Plug those on together. We are going to get 153.20 grams moles. Now that I introduced them individually, let's compare them. For functions, serotonin focuses on mood, appetite, and sleep. Dopamine focuses on motivation and behavior. Associated behavior, serotonin mainly has depression and anxiety. Dopamine has Parkinson's disease, schizophrenia, and addiction. Deficiency, serotonin may increase aggressions and suicidal behaviors, while dopamine may increase the lack of motivation and loss of interest. And for receptors, serotonin only acts with serotonin receptors, which is 5-HT receptors, while dopamine only acts with dopamine receptors, which is D1 or D2. I have a few questions to ask. First, why do drugs contain serotonin and dopamine, and who is most likely to use these drugs? Antidepressants surprisingly contains both. It's a medication to alleviate symptoms of depression by affecting the balance of chemicals in the brain, which includes both serotonin and dopamine. It helps with improving mood, sleep, and how we feel. Many antidepressants include serotonin dopamine activity modulators, SSRI, which can help with mood swings and emotions. Some generic brands that include SDAM are brexpiprazole, Caplyta, and lumateperone. Well, who takes antidepressants? Well, people who suffer from depression do. It's actually the most common way of coping is through antidepressant. It's a mental disorder that affects how we feel, act, and think. 21% of adults in the United States suffer from depression. 1 million people take their lives each year, and 75% of people remain untreated or don't seek for help due to fear and the cost. The real question of this whole project is, why do so many drugs resemble the structures of serotonin and dopamine? The truth is that antidepressants have a structural resemblance with neurotransmitters like serotonin and dopamine. This drug is helped to design neurotransmitters engage and transport in the brain. which binds receptors to give signals to make change in both the mood and behavior. Resembling these structures can depend on the level of serotonin and dopamine, depending on the person. So the next question is, how do neurotransmitters like serotonin and dopamine interact with receptors in the brain? This is a 4-step process, but I am here to break it down for you guys. The first step is that the drugs react with the neurons through the neurotransmitters. The chemical structure allows the drugs to activate the neurons through the brain. The second part is that both the serotonin and the dopamine bind receptors that travels through the synapse to bind the specific receptors on the surface of the neuron and is ready to deliver both of the neurotransmitters. The third part of this process is that during this transmission of signal, the neuron receives a lot during this part. It can go 2 ways. It can become excitation or inhibition. It depends on whether the receptor type is within the brain during the time. The last part, the fourth and final part, is that once the transmission is done, it can be removed from the synapse to get a signal. It will be sent to the neuron and it will begin to break down the neurotransmitter in the synapse, which cause reaction. So what happens if there's too much serotonin in the brain? Well, you can develop serotonin syndrome, which is caused by the amount of serotonin levels in the brain caused by the medication. A few ways to show that if you have the syndrome is through confusion, major headaches, shivering, and dilated pupils. Also, this is a life-threatening situation. Well, what happens now if you have too much dopamine in the brain? Well, you can show hypothalamic states. It's basically high levels of dopamine in the brain and it can become dangerous. A few medical conditions that is connected to this is Tourette's syndrome, ADHD, schizophrenia, and substance use disorder. Secondary treatment is given depending on the medical condition that is developed. Final thoughts is that neurotransmitters like serotonin and dopamine are mainly based in antidepressants because people take these to feel better about themselves, to overcome depression, and to overcome tough challenges, to relieve new energy, more happiness, and motivation. And understanding how these two neurotransmitters breaks down in the brain to release all this energy is absolutely mind-blowing. So how does this connect to Chem 1031? Well, in the beginning of the semester, we were taught chemical structures from the start. I hope you guys break down how to find the chemical structures for both of the neurotransmitters. The second is we learned about the molecular weight, and I gave you guys a refresher of breaking down step by step to find the molecular weight. The third reason is that the concept of understanding how neurotransmitters deliver in the brain. And then lastly, we can apply chemistry to real life scenarios. This topic is really important because we have to understand the intake of medications and it has a lot more meaning than what we think. Swallowing a pill and that's it. We have to understand how a pill that we swallow interacts with our brain and releases energy and releases the outcomes of the pill. And then we have to understand the chemistry behind both the serotonin and dopamine, break it down through the brain. I hope you guys enjoyed this presentation and I hope you guys have a nice winter break, and these are my sources.